In the water, the ratio of the hydrogen and oxygen is 1:8. That means that if 9 grams of water is decomposed, 1 gram of hydrogen and 8 grams of oxygen are always obtained. 1:8 means that is a water. If for suppose if 9 grams of water decomposed, how it is 9 grams? 80 grams of oxygen, 1 gram of the hydrogen, total 9 grams. If 9 grams of water decomposed, then 1 gram of hydrogen, 1 gram of hydrogen and 8 grams of oxygen are always obtained. And 8 grams of oxygen always obtained. Okay. If 9 grams of water decomposed, 1 gram of hydrogen and 8 grams of oxygen always obtained. In the same way, similarly in ammonia, if we take the ammonia formula NH3, nitrogen and hydrogen are always present in the ratio 14:3 by mass, whatever the method or the source from which it is obtained. Okay. For suppose similarly, if we take the ammonia, ammonia formula NH3, ammonia formula NH3. Okay, in this nitrogen is there and hydrogen is there, so these nitrogen and hydrogen are always present in these nitrogen and hydrogen are always present in the ratio. What is the ratio? Can you guess? In the ratio 14:3. What is the ratio? 14:3 by mass. 14:3 by mass. Okay. This is about the ammonia and water. So what is the ratio? How can we find out this ratio 1:8 and 14:3? How can we can find out this ratio? Based on the molecular formula. Based on their formula, we have to find out. For suppose, if we take the water, okay, mass of water is, we know, 18. How can we calculate that mass of water is 18? Here hydrogen is there, oxygen is there. Hydrogen atoms are 2 atoms is there. Hydrogen mass is a 1. Each atom contains the molecular mass is a 1. Okay, hydrogen atom mass is a 1, but 2 hydrogens is there, that's why 2. Okay, remaining element is the oxygen. Remaining atom, 2 hydrogen atoms, 1 oxygen atom. 2:2 oxygen atom. Oxygen mass is a 16. Atomic number 8. Mass number 16. Hydrogen atomic number 1 and mass number also 1. Already we are discussed in the 8th class in the previous chapters. Okay, 16. 2:16. Here 2 ones are 2. 2 8s are 16. So what is the ratio of the mass? 1:8 for H2O. Here already I told, here 1:8. If 9 grams of water decomposed means 1 gram of hydrogen and 8 grams of oxygen. 1 gram of hydrogen, 8 grams of oxygen. Okay. In the same way, NH3, ammonia. Can you calculate the ammonia? Ammonia is of 14:3. Why? Because nitrogen 14. Hydrogen is each hydrogen contains mass is a 1. So here in the NH3, nitrogen is how much mass of nitrogen? 14 is to. How many hydrogen atoms is there? Here 3 hydrogen atoms is there. Each hydrogen atom contains the mass 1. 3 hydrogen atoms mean 3. Okay, this is 14 is to 3. Mass of NH3. Okay, mass of NH3 is 14 is to 3. Water is 1 is to 8. This is the method of calculation of ratio of the masses. Ratio of the masses. Okay, now what is the law of constant proportions? How can we define the law of constant proportions? This led to the law of constant proportions, which is also known as the law of definite proportions. Law of constant proportions we can call the law of definite proportions. This law was stated by Proust. Who is proposed this law? This law was stated by Proust. As in a chemical substance, the elements are always present in definite proportions by mass. This is called law of constant proportions or law of definite proportions. Here, what is the law of constant proportions? Law of constant proportions. Okay, what is the law of constant proportions? Law of constant proportions. Law of constant proportions. Law of constant proportions are also known as, which is also known as the law of definite proportions. Law of definite proportions. Law of definite proportion. Definite proportions. Okay, so the law was stated by Proust. The law was stated by Proust. Proust is a scientist. The law was stated by Proust. Okay, so what is the law of constant proportions? In a chemical substance, the elements are always present in definite proportions by mass. In a chemical substance, the elements are always present. The elements are always present. In a chemical substance, the elements are always present in definite proportions by mass. Definite proportions. Definite proportions by mass. In a chemical substance, the elements are always present in definite proportions by mass. This is called law of constant proportions or law of definite proportions. Okay, so after that, Dalton picked up the idea of divisibility of matter. Okay, generally matter, already we in the first chapter and second chapter we are discussing about the matter. Okay, in that, matter is made up of small particles, that is called atoms. Okay, then he took the name atoms as given by the Greeks. Atoms is given by the Greeks and said that the smallest particle of matter are atoms. Dalton told us the smallest particle of matter is atoms. His theory was based on the law of chemical combination. Dalton's atomic theory provided an explanation for the law of conservation of mass and the law of definite proportions. Okay, Dalton given the smallest particle of matter is a atom. It is depends on the Dalton atomic theory provided an explanation for the law of conservation of mass and the law of constant proportions. Okay, according to Dalton atomic theory, all matter, whether an element, a compound, or a mixture, composed of small particles called atoms. Okay, according to Dalton, the smallest particle is the atom.